Hello, ladies and gentlemen. So this is Mr. Ortiz, and our focus today is solving linear and quadratic equations. And our focus is going to be graphically solving these, where as we go through the year, we're going to learn how to do it algebraically again and get exposed to some other methods as well. So as we begin, we have three different cases that we'll explore. One solution, no solution, and infinitely many solutions. And notice that there's f1 of x and f2 of x. We're going to take each equation and break it up into two functions. And where we start is with the equal sign. And so for each one of these, we're going to come to the equal sign, and that's where we're going to draw a little break in. And so we're going to separate that left side and that right side into these two different functions. So here, for the left side, we have 6x minus 10. And for the right side, we have 4x plus 4. So we're going to make a graph page and graph these separately, but on the same grid. So if you're at home, we can use the DESMOS testing version of the calculator. So we go DESMOS Texas. There's our DESMOS Texas star version, and we can see it down here too. But if you search for it, it'll be this one right here, and you can see Texas star version. Okay, so we'll graph the first function, which was 6x minus 10, and the second function, which is 4x plus 4. And now keep in mind, I'm using the keyboard here. However, there is a little math pad down here. You can get your letters. You can come back to the variables and the functions and the operations. Now what we see here is we see two lines, and hopefully you can see that one line is slanted, is less steep than the other, and so they're going to intersect. We can see a second thing, that right here the white space in between these lines is thicker here than it is here, so they're getting closer up here. We can zoom out, and that's what these buttons are for, zoom in and zoom out. So let's zoom out and zoom out and zoom out. And at this point, we can see that they cross right here, that there's an intersection point. Now, if I click on the lines, so here along the blue line, it shows me important points like the y-intercept, the x-intercept, or the 0. And we can see right here where the two lines are crossing, we have an intersection point. So 7, 32. So coming back to our notes, that's really it. That I'm gonna have to graph both sides. I'm gonna zoom out if I can't see the intersection point or the graphs clearly. So this becomes our solution, but not the whole thing. If we go back to what we started with, up here, there's just x. There's just x. So we'll use our highlighter to kind of help us out with here, that we have just an x value. So we're looking for the value of x that makes our equation true, and that's what this x value is right here. That's going to be our solution. So we state x equals 7. We'll highlight that as well. Okay, so now as we come back up here, we can do the same thing for no solution and infinitely many solutions. But let's talk about what we've just done. So what we've done is we found out that x is 7. So on this side, we have 6 times 7 minus 10. But 6 times 7 is 42. And if we subtract 10 from that, we get 32. Okay, so that's taking our solution of 7 and plugging it into the left side. Well, let's do the same to the other side. So now we have 4 times 7 plus 4. Well, 4 times 7 is 28, plus 4 is 32. Oh, and look at what we see here. That when we plugged in our solution of x equals 7 into the equation, we get a left and a right side that are equal. And so that's what our solution is. It's finding a value that we can substitute into the equation that gives us a true statement. Okay, so we do the same thing here. And we want to graph both of these. So 6x plus 2, which is our left side, and 6 parentheses x plus 2, close parentheses, minus 8. So as we come back here, I can click and I can use the x's to delete those, or I can go here and delete all. So little cogwheel and delete all. So we have 6x plus 2, and here I'll just kind of model using the touchpad or the math pad. Okay, that's our first function, the left side. Now the right side, 6 parentheses x plus 2, close parentheses, minus 8. Now, as we do this, what we can notice, and if we want to zoom in a little bit, we'll notice that these lines are parallel, and we can see that the thickness between them doesn't change. And so as we kind of look left and right, we can definitely see that they're not getting any closer whether we go left or right. Here, we can go back to the home screen, which is that just default page, X min max, Y min and max that we have here. Now, for this one, we can conclude that there's parallel lines. So because there's no intersection, there's no solutions. Yet again, because they're parallel, they'll never intersect. Okay, we have one last case to take a look at. And yet again, the left side here, 5x minus 15 is our first function, and 5 parentheses x minus 3, close parentheses, is our second function. So we can go and delete those again. And I like the keyboard more than I like the little touchpad there, but it has some things that are a little more intuitive than the keyboard. So you can kind of see the exponents and the square roots. Okay, so now that we have both of these, and I want you to notice this, we didn't see the other line, but hopefully you did. Oh, it's right behind this one. Oh, they're on top of each other. And so if we talk about where they're intersecting, technically they're intersecting at every one of these points along the way. And that goes forever left and right. So as we talk about where does it touch, it touches everywhere. And what we call this is that there are infinitely many solutions. So there are infinite solutions, and you know what, let me do this because I don't like my work there. Whoops, I guess it doesn't want to let me fix it. So let me see if I can. So there are infinite solutions. Okay, and so that concludes our first section here. And what I'd like you to do is knock out 1, 2, and 3 on your own. And then from there, you can ask me to check in class, or you can come into class prepared with that for me. So I know, hey, you're ready to move on to the next part of the notes or the assignment. Okay, so you can pause my video there. And then when you're ready, we'll move on to that next part. Let's see how much time. Okay, so this last one, we go into graphing them again. So we have our left side and we have our right side of that equal sign. Now notice that the right side is pretty simple, that it's just x equals 2. So here, oh, whoops, not there. We're breaking apart that equal sign yet again into that left side and that right side of it. But sometimes the right side is very simple. Here yet again, as we do it, yet again that left side and that right side. And so sometimes it can be more complicated or less complicated, but when we decide where do we break it apart, the equal sign is where we do that. Okay, so as we graph these, and so what we'll do with this first one is I'll really just kind of focus on one of them. So we have x minus 3 squared. I need that true power, and that's important. So we'll clear them out. So we have parentheses x minus 3. And it's squared, so I need this A2 button. I could use this one here So let's see what they both do. That squares it. This one raises it to a power, and then I have to type 2 and then move out of the exponent's place. So that one's a little more convenient for the 2 power. And let's see, what else do we got? And then plus 2 outside the parentheses. So we get a quadratic function. The second function was just 2. So this is a constant function. It's a flat line. Now, this is kind of funny. So I didn't think I'd run into this problem. So it's not graphing just 2 for us. So what we can do is we can say y equals 2 to let us graph it here. So we're just having to have that y equals part in front. And I think it's only because it's a number, so it doesn't know if we want to add or subtract or if we want to graph it. So this is how we can say graph my number. We'll notice here that this quadratic function and this linear function intersect right here at 3, 2. But yet again, as we come back to it, what is our solution when they intersect? The solution is the x value of those intersection points. So here, positive 3, oops, wrong color, is our solution. And there's only one. But because quadratic functions have a possibility of 2 intersection points, we can have 2 solutions. And so we'll see this on this next one that we have 2 different solutions. And we can write them as x equals -3, -4. We can even put them in a solution set where typically they put them in order. So negative, the smallest to the biggest. So 2 ways to write that. And yet again, so I'll show us that one. So we have x squared minus x minus 12. And then we have 0. And yet again, it's probably not going to graph 0. So if we have a number, I got to put y equals for DESMOS. And we can see that they intersect here actually on the x-axis. These are zeros of the quadratic function. And so here, -3 and 4 are solutions. There's 2 because there's 2 intersection points. So always look for a second one if it's quadratic. Does it always have it? No, but it can. Okay, and our last example here, yet again, we can have the graphs where they do not intersect, they do not cross. But since they're both not lines, they're not parallel. They're just non-intersecting. Okay, so we have 2x squared. And the other one, we have -1 divided by 2x and minus 4. Okay, so as we graph this here, now what we can see is well, that they don't cross. And we can zoom out to see even more, but they're never going to cross. Now, there's one special thing here. There are no solutions. That's how we can consider it. But as we talk about the real set of numbers, there's no solution there. However, there is a solution somewhere else, and we call this no real solutions. So as we get later into the year, we'll talk about complex solutions. And in Algebra 2, we'll go even deeper into that concept. All right, so yet again, down here at the bottom, 4, 5, 6, 7 would be ones I want you to do on your own. Show me you got it. And then you can move on to that practice assignment. And then if you need some help here, well, this is definitely where I can help you before you move on.